it will have some velocity u. It will be having a velocity say v, not at highest point. So it will explode. Due to explosion, two fragments will come. Say 2m. What about the other fragment? How we should move? Instead of three, only two fragments. What should be the other fragment? How we should move? Other fragment, shall I take it like this? Or other fragment should move vertically down. One fragment, I'm taking m, other 2m. This is one of the situation. It can happen. Another situation, say, have a generalized idea, nothing is there. So again, explosion occurs. So here what? Explosion took place. Again, explosion occurs. So due to explosion, now one of the fragment will move like this, I'll assume. This is totally different situation. Another fragment, can it move like this? Which one will occur? Yes, anything can happen. No? So based on that, the velocity is v2 and v1 when you calculate here will be different. So I'll do one thing. I'll put some other different symbols. It'll be easy for you. So here, somewhere at a height, it will explode where it will have velocity. Explosion occurs. Now due to explosion, it can happen like this, it can happen. So calculate v2, v1 will be different than v3, v4. And I can also bring one situation. What is that? Energy released in explosion, a part of that 1/4 or half will be utilized for imparting kinetic energy of fragments. Then you have to bring that E0 also. So E0 is energy release filter. So how the equations you are going to write? So this will be, now first how to calculate this V, how to calculate that V square minus U square equal to 2 minus G into H. This will be given for us. U and H will be given. At what height? So we know V is equal to U square minus 2GH. Then applying conservation of momentum, 3mv equal to 2mv2 plus mv1. V2, V1 both are unknown. I'll apply conservation of mechanical energy. Here all the energy is utilized for imparting that one. So this will be 2m v2 square plus m v1. I think the same story, no, nothing to do big. Here the conservation of momentum will be 3mv minus 2mv3 plus 2mv3 minus mv4. Anything can happen. Fragments both can move in same direction. Two fragments can move in opposite direction. What situation E gives, based on that you have to write down the equation. So for this it will be, for this it will be 3m mv4. Again the energy equation will be E0 plus 2m v3 square by 2. Okay, so proportionally v3, v4 will adjust that values. So have this generalized idea. E0 is energy released. Energy released during explosion. So when momentum should be conserved during that, due to explosion only, not when explosive 3m is ascending up. Here now momentum is not conserved, no, because weight is acting. Only during that explosion is what momentum must be conserved. I think we have to slide. Yeah, one more. It's a very good problem, is there? Projectile motion. We'll discuss something about related to projectile here. Horizontal range, a lot of information you are supposed to analyze is telling horizontal range. So how is projecting? It's like a projectile motion, no? Knowing that the horizontal range of the shell would have been R if it were not exploded. Predict location of mass center of two fragments relative to location of firing when the fragment A hits the ground. Okay, now we'll just revise our theoretical ideas. Actually, what happens in projectile motion? It's some very generalized discussion first. Let's have. So this is some, you can say, fragment of mass 3m, or also like a mass m. I'll project with a speed u at an angle theta. Now what will happen to this? It is going to describe a parabolic path. This what happens. If there were no explosion, so what would happen? Definitely will come and strike. There's a point of projection O. So it would have come and strike at this particular point. It will describe parabolic path. It will come and strike the ground at a distance r. What is r? R is the range. R is the. I'm not discussing the question. I'll come to later on. Let me give a general idea. So now explosion occurs. Due to explosion, so it depends, one of the fragment, if it is at a distance of, if it falls here. So let me take that as m by 3. So at what distance it will fall? At r by 2. Where the other fragment should be. The lighter fragment will be here. Where the heavier fragment. So explosion, where explosion occurs. So let it be, let's say that explosion occurs. And due to explosion, so it depends, one of the fragment, the lighter fragment of mass m by 3 will fall at this particular point. Where the other 2m by 3 should be. No, this is the path of center of mass. Whether, though what happened, explosion occurred, still what happened, the center of mass is going to describe that parabolic path as if no explosion occurred. And where the other fragment, path of the other fragment will be somewhere like this. And it will come here. This is the heavier fragment, path of. So what should be the mass of heavier fragment? 2m by 3. Can we calculate this distance I want? So this should be the center of mass, no? When finally they strike the ground. So I'll use m1x1 equal to m2x2. So what is the formula? M by 3 r by 2 should be equal to x 2m by 3. So what should be the value of x? R by 4. And we know center of mass should lie heavier, near to heavier mass. Is it okay, no? So this is the overall basic picture. Now, say if the lighter fragment falls at the point of projection, if the lighter fragment comes here, where the heavier fragment should be, then instead of r by 2, what you should write? You should write r. Then x should be equal to 2r. It will come on this side.
Sir,
Yeah.
how did you equate both, sir?
m1x1 equal to m2x2. Because net force acting on system along x-axis. 0. So delta xcm 0. So m1 delta x1 should be equal to m2 delta x2. Got it? So that see, center of mass, do remember one thing, m1 delta x1 equal to m2 delta x2, or m1 delta x1 plus m2 delta x2 should be equal to 0. From there is what I brought it. Because center of mass will not undergo displacement. Along x-axis, net force on system along 0. So m1 delta x1 equal to m2 delta x2. If explosion were not occurred, what happened? The particle, the explosive would have been here on. Due to explosion, what happened? The fragment series. So how much the lighter fragment got displaced? So m1 delta x1 should be equal to m2 delta x2. So I think some information I'll give it. So this I'll call delta x1. Now let's write the. So you want that mathematical way. So I'll put it now. So this should be m by 3 delta x1 plus. Okay, ma. This one. If you measure delta x1 negative, delta x2 should be positive. Okay, now is asking. So what all can happen here? The path of other fragment. What all other possibilities? The lighter fragment, if it is here, so then m3r should be equal to what? To m3 into x. Then calculate the x value. Then can it happen like this? A lighter fragment will come on this side. Yes, it can happen. There's no rule that one. It all depends upon, and provided what happens, the energy should be conserved. Overall energy should be conserved. Explosion occurs here, and explosion, can it occur here? Yes, explosion can occur here. Explosion can occur here. Okay, now based on this analysis, now come to this question. Read now. It will be much easier for you to analyze. Horizontal range. So look at that one. Before highest point. So this what I just picked up this question because of this one. Before the highest point. So draw the trajectory first. So go for the trajectory before the highest point. So let's have a diagram. No. Now this is explosive. Then it's going to describe a parabolic path. Now this is the highest point, no? What we know. So this should be the highest point. Maximum height. I am projecting with a speed u at an angle theta. Somewhere here is what explosion occurs. I'm just putting red mark. I think it is understood. It's explosion. Now, what is the state of this? That explosive, it will be having some velocity v. Now, let's come to the question. The fragment A immediately comes to an instant rest and then falls. So there are two fragments are there. There's a one fragment. Knowing the horizontal range of shell would have been R. If it were not exploded, predict location of mass center of two fragments related to A and B. Two fragments A and B somewhere before the highest point. What about the other fragment? The other fragment, I'll take it. Be like this. Immediately come to rest and it will fall. So this will be position of fragment A. And it's the ground. What about the fragment B? Fragment B is going to describe a path like this. Where it should be? Will it come and strike the, and this is the path of center of mass, no? And the fragment B will be like this. Path of center of mass, and let me take just for so that we can study in detail all things. There's a maximum height ascended by the fragment B, and fragment B finally will come and strike here. Now, what is the thing? It will take time t to come and strike it here. Now during that time is asking on the ground. So where the when the fragment A hits the ground is asking where the center of mass will be. So this will descend some height, no? HA you call. And the fragment B will have immediately some velocity. So look at this. So what is the time taken by the fragment B to come and strike the ground? Will it be equal to T or greater than T? You look at the velocity. That's why I just picked the previous problem, T1, T2. What should happen to this? They should first ascend, attains maximum, then reaches, no? So definitely the time taken for this green color path should be more. The time of flight of green color the fragment B should be more to strike the ground than this one. So when the A hits the ground, where the B will not be here on the ground. The B will not be here on the ground. So where it will be somewhere here. Sir, how do you can say that? The B will be here. When B is here, where the center of mass of system will be? Somewhere at this point. So is it striking the ground? No. Is it okay? No. So is it striking the ground? Sir, how do you are analyzing all this? There should be some method. So one thing, time taken by the fragment B to move from say like a point 1, 2, 3, and time taken by the fragment A to move from 1 to 4. So T1 4 will be less than or say like a T1 2 3 should be greater than T1 4. At least we'll agree. So from how you are saying that one, from kinematics, if you drop an object and you project an object, tell me which will strike the ground earlier, the one which is dropped, no, from height. Go back to projectile motion. That we have to apply it. Now look at this. This should be the range, no? This should be the range. It's a very good problem where there's a range. And look at the center of mass. It is at a distance less than range, no? So on the ground at a distance that is equal to r, ruled out. In the air at origin that is equal to r, no. In the air at origin that is less than